which that server has got an array list. And you've got your own computers. You've got at least one class and one interface configured in RMI. Simply what you are telling in your system, I can be called remotely. Okay? Or this class methods can be called remotely. I've configured them, but I'm not sharing them over a server which people can look me up. Okay? What you said, I will give you my reference. What you've just said, you came here and looked that machine up because this has got an RMI registry. But you told that machine, the centralized machine, oh hey, can you please have this reference for later use. So when you called the first method, you looked this system up, right? You called look toker. You've got access to the toker method. One of the methods is take my reference for later use. And you pass the reference to the remote class in your system. Does that make sense? When you pass that reference here, this machine then can call your methods. That machine can cast it, okay, to a local reference of your systems and can call it. For example, if that's a drop-the-box application, you've got one server and many clients, okay? The clients know the direction. The server don't know yet about your machines. How come the server knows your machine IB so it can call it whenever the server wanted? So what is happening then in your application locally? Your application has already been configured, if it's Java for example, as RMI architecture. When that client you've downloaded and installed looked up the server, it did send a reference to your machine to that server. So later on the server can just call method locally, but he don't have access to the objects in your machine because you've got the files. He don't know about the new files, but the execution of these methods will happen in yours. So both of them. So you are sending the reference. That's the key now. This client is sending a reference to the server for later use. And because that reference has already been configured as RMI architecture, so therefore that computer too can call the method too. So what's happening now? It's two-way communication. So let's make it a bit simpler. That is the exercise in the labs for tomorrow. It is simply a chatting system, a real-time chatting system. Okay? If we're gonna develop a chatting system which is near real-time, what would you do in your web application? What would you do? You've got all of those clients are gonna open a chat room. How would you maintain the real time between them? It's not this. Your own.
Using Socket.io.
One.
Socket.io and web.
So what do you do? Go on. So you have one server or more than one server?
It's just one server.
One server?
Yeah, and every client is supposed to connect to that server.
Yep.
And you have an interface, web interface then.
Yep.
They say it's JavaScript.
Okay.
So whatever you post, whatever you.
Yeah, you click button, it will send it to the server. How the server will send it back to all of those clients?
I suppose it shows it on the interface.
And the interface, how the interface will get the messages of the other people typing?
They are connected to that interface, as far as I can remember.
How would you refresh the messages in the server?
Each client is connected. Each client has its own socket channel that they're listening to, and when they send in the message, server decides where the socket, to which socket to send the message to.
So you're still socket programming, primarily, which is a lot. It's a lower level than even RMI. What other possibilities?
You could have it hit bits at every
Oh, beer to beer. So you keep track with all of those beers while they are on. Oh, that's okay. When I developed it, that is more complex than here. When I developed it when I was a second year or first year, I just had a refresh screen every 10 seconds. So that is refresh the screen, call another SQL, which pulls the data again and again and again and again. But not real time though, this is real time. This is real time. But at lower level than using RMI. The idea here is you can have the server, and the server has got a list of references to all of those clients on the system. When a new message comes, the server will call a method in each one of you guys. And that's real time. And you don't do any socket programming, because obviously the socket programming is here, and it's been done in this system. It's been written already, so you don't need to be bothered about that. Yes, it uses socket programming here, and TCP/IP communication, etc., rather than peer-to-peer. Okay? Therefore, you don't need to be bothered about that code. Okay? I was bothered some time ago, 5, 6, 7 years ago. But now, I just call a method in the server. Whenever I receive a message, whenever somebody calls send message to the server, I go in a for loop over the vector of the people I know they are enrolled into that room, and I call a method in them, and the method will be executed locally. But before we go there, let's just look what's happening here. That is the assignment, or that is, let's say, the work we're gonna do in the lab. I've got here RMI chat server implementation. I've got RMI chat server interface. I assume you are getting on board of what is supposed to be in these two classes, or one class, one interface. Here, extend unicast remote object implements the interface. Here, extend remote. Agreed? That is implementing, or let's say, that is following the RMI architecture. As a result of that, that class will have a skeleton underscore skill. And that class will have a stub, which is going to be sent to the client, RMI chat server implementation underscore stub. So when that client look up that server, it will down reference the stub. So that's the communication vehicle between the client and the server. But then there is another thing here. Look at the client. The client has got RMI chat client implementation, and it's got an interface, and it's got a skeleton. What does that mean? That means the client extended unicast remote object, implemented the interface, and the interface already extended remote. Therefore, this is also inherited the RMI functionality. But there is one small difference, and it's got a skeleton, and the skeleton is talking to the server. Okay, so the server has got a copy of that. How the server got a copy of the stub for the client? When the client looked up the server and down referenced the stub for that server, it did say in another method, hey, can you have a reference to me so you can talk to me later? Okay? So therefore, this server can call methods into this client, and this client can call method in the server. It's two-way communications through methods calls. Through methods calls, not socket, not peer-to-peer, not refresh the page. Through methods calls. So if there is any change in here, and that server needs to communicate that change, it will need only to go over that vector or array list and call a method on those clients. Obviously, it's not an observer design pattern, not an obsolete great example, because we are only maintaining a single a reference of the same type. But what we've just managed that if I create 10 instances of this chatter, which is the interface, those 10 instances distributed all around the world can look up the server, down reference a copy, and send backward to that server a reference to themselves, and they can, whenever somebody send a message to that server will send that message to everyone again, including that chatter himself, the sender. And I've done it this way rather than the chatter. If the chatter sends a message to the rest and just populate his own, I thought it's better idea to allow the server to send back the message, so you can see the delay going to the server and coming back. So you can see how long it does it take for everyone else to see your message. Okay? And that's it. The whole idea here is method calls. So, for example, if I am the server here and you've got the chatter clients, that server here is responding to everyone by calling methods in each one of your computers. Nothing other than that. The rest, the underlying architecture, I am talking the stub and the skeleton. Again, the stub and the skeleton, because both of them maintaining the skeleton, the stubs for each other, right? The remote reference layer, the transport layer, which is the socket layer, you are not bothered about at all. This is all done for you, and you are just calling a method locally, but the execution will happen remotely.